Assalamu alaikum everyone. We will be starting just in a while. Thank you so much for joining us.
Hello, Assalamu alaikum everyone. This is Zainab again from DICE Analytics, and I welcome you all to the second round of DICE Webinar Series 2021, Data Warehousing and Business Intelligence in Modern World. I'm excited to announce that our speaker for today is Mr. Awais Hijaz, who's currently working as Solution Engineer Manager at Teradata. He has an extensive experience of 8+ years in the field of data science, analytics, business intelligence, data warehousing, and big data. Today's webinar will provide you a platform where you can discuss all your queries with Mr. Awais about the technicalities of data warehouse and business intelligence, its career pathways, and scope in Pakistan. Furthermore, Mr. Awais will be guiding us about what is actually data warehouse, building its layers, business intelligence overview, role of big data in data warehouse, modern data warehouses over cloud, and much more. So make sure to note down your queries to ensure that you have discussed each and everything and clear all the queries in the Q&A session at the end. That's all from my side. Thank you. Over to Mr. Awais.
Hi, hello everyone. So Zainab, can you please confirm if you can hear me loud and clear?
Yes, we can.
Perfect. Great. So let me just share my screen and just give me a confirmation when you are able to see my screen.
Yes, you're good to go. We can.
Great. So hi everyone. As Zainab mentioned, my name is Awais Hijaz, Muhammad Awais Hijaz, and I'm working in Teradata as a solution engineer, basically as a pre-sales technical solution architect. I am associated with data analytics and data warehousing industry since 2012. So it's been roughly around 10 years in the industry now. And I have worked with different telecom companies and different banks in financial industry in Pakistan and outside Pakistan as well. So basically, I started my career as a data engineer in 2012 with the same company, Teradata. And then, I went through a natural progression of from a data engineer to data modeler, and then solution architect of data warehouses. And then now I'm focusing on pre-sales, architecture level and design level stuff in Teradata. I had a 1 year gap, I would say, from Teradata when I joined IBM, and I was leading their data and AI technical sales for Pakistan, Afghanistan, and Bangladesh from 2019 to 2020. So that was some basic, a brief introduction around myself. No, I would like to, make this session more sort of an interactive one. And I would like you guys to, introduce yourself. If if there is anyone who is willing to participate with me to make this session more interactive, I'll give you a chance to introduce yourself. So Zainab, can we unmute any of the participants, anyone from you, if you guys can, volunteer and raise your hands, so we can give you a chance to, introduce yourself, so we get to know.
Yes, you have the hosting rights. You can unmute the participants.
Right. Let me just. So we have Kumar, Lukesh. Kumar, I've given you the rights. You are now allowed to talk. You can just unmute yourself and just tell us something about you, your name, your experience, and your expectations from the session. So Kumar, you just need to unmute yourself now. I've just allowed you. Ramzan Badr, if you can hear me, you are also allowed to talk now, and you can proceed to introduce yourself. I have also allowed Aman.
Can you hear me all?
Yes, we can hear you loud and clear.
All right.
Welcome.
My name is Badr Adam. Assalamu alaikum all, and I have done my master's in supply chain management, and currently I'm doing job in AI-based company as a supply chain analyst. And so
Great.
far as my field is concerned, I am doing this job for last 2 years, and I have experience in data management, data analytics, moreover reporting side and customer services. And overall, my experience horizon is fall about around 4 to 5 years.
Great, great. Player knowing you, Badr.
Thank
So
you.
I'm sure data analytics is helping you in your day-to-day supply chain.
Yeah, obviously. Like currently, I'm only working with Power BI. Like joining this webinar and getting about know-how is my core area is to enhance my expertise in data analytics, business analytics, especially in the tool of Power BI, and
Mhm.
about data warehousing. Like we need to work with Power Cube, and there is some sort of technicalities which I'm looking forward to learn with some sort of institution, so I could do all of my work independently.
Great, great, perfect. Player knowing you, Badr. So what next? Kumar, we have allowed you. If you can hear me loud and clear, then please proceed and introduce yourself. Or I've also allowed Mohammed Noman and Adil Iqbal Khan. So Noman, yes, please go ahead.
Sir, can you hear me?
Yes, we can hear you.
Assalamu alaikum everyone. My name is Naman Ahmed, and currently I am having my master's in data science from Bahria University, Islamabad. So my purpose to join this webinar is, as I have recently studied big data. Recently I have studied the degree. I'm just entering my and starting my career. So I found this is very useful for me, and then how to practically implement big data and how to use data warehousing. And I have theoretical concept, but how to practically implement that will be helpful from this seminar.
Great. I hope we'll help you in this aspect. So, Adil Iqbal Khan, I have allowed you to introduce yourself. Obviously, I know you, but if you want to introduce yourself for the rest of the audience, it would be great. Player to have you in the session. Adil bhai, you need to unmute yourself if you can hear me. Seems like Adil is not there. Kumar, are you there?
Yes, sir, sure.
Yeah.
Can you hear me?
Yes, we can hear you.
Assalamu alaikum, sir. My name is Lukesh Kumar, and I have recently completed in computer science from Islamabad, Capital University. I'm basically belong from Tharparkar, Sindh.
Great.
And today is my second section of round 2 webinar.
So Kumar, what are your expectations from this session? Is there any specific thing you would want to learn in this session? I mean, obviously we'll try to give you a flavor of what databases are, what data warehouses are, and how the market is progressing and how the modern data warehouses are coming into play. But is there anything specific you would want me to highlight? So one more introduction from the audience. Zuresh, please go ahead.
Hey, Assalamu alaikum. Can you hear me? Can you hear my voice?
Yes, we can hear you. There's a little bit of echo, but we can hear you.
Yeah, I'm sorry, sir. I'm in office right now. So basically, sir, I'm going to be graduated in this year, and I'm going to pursue my core degree in data warehousing and BA analytics on minor path. So, my main focus is on DWH. So I want to find out what is the big difference between as being a data scientist and as a data engineer. What is the advantages of choosing between these two roles? how would you suggest people to choose between these two designations, data science and data engineering? Which one would be the lasting in the next century, or which will have a bigger impact?
Right, right. So we'll discuss these personas associated with the data analytics industry probably in the next couple of hours, and I'll surely try to guide you what to choose and how to choose. Basically, it depends upon your interest. Both of the roles, both of the personas you mentioned, the data scientists and the data engineers, both will remain there, and both are you know not exactly overlapping in terms of capability. So both have their own role, and both have their a very important role to play in the overall data analytics scheme of things. So I personally believe that both are important, and it depends on your personal inclination towards both.
I have one more question. It is if a person spend more than 5 to 6 years in data engineering, because if you don't actually become a data engineer in a year, it requires 3 to 4 years to become a data engineer properly. So if a person wants to switch after being data engineer for 5 years, so to data scientist, so is that difficult to switch between these two fields, or it depends upon the effort?
No, it is definitely not difficult to switch between different roles within the data analytics ecosystem, right? But in fact, it is going to be the best case if you start off your career with data engineering side, so you get to know how to process data and how to play with the data, and then you move towards or progress towards data science related stuff. Generally we have seen in the past that many people in the data science domain, if they don't have prior experience in data engineering, they really struggle in processing and transform the data according to their own requirements. So it is definitely doable, and it's a good way to go about it. So if you don't have any further question, I'll
Just
proceed
one more.
to another
Yeah,
part.
just one more.
Sure.
Attending the seminar, and what would I gain from this, and what would be the aspects in both fields, in BI and as well as DWH, and are you going to discuss about the futuristic jobs that is going to overtake by this, or you will also help us find out which best tools are in the market to work on?
Brother, I'm really sorry. I couldn't actually get your question, but if it is around the job market and the roles, so yes, we'll slightly touch.
Let me clarify, sir. Sorry, let me clarify. I just want to find out that this seminar, will this seminar also help us in identifying which best tools to work around in the DWH, which includes the transformations process or the reporting tools? Will this session discuss that too? Or it's only discuss about the history, or it discuss the working of in both areas of DWH and BI?
Yeah, we'll slightly touch upon the working and the architecture.
Sorry, I'm not hearing your voice.
On that, or for a detail, any other courses which are specifically targeting to these kind of areas. So we have a question from Akib in the Q&A, that is it possible to question in Urdu? Akib, please go ahead. I've allowed you to speak. Please go ahead and ask any question in Urdu or English, whatever. I definitely can.
अस्सलाम वालेकुम, आप सुन रहे हैं?
Yes, we can hear you.
So that is why I am
जी अस्सलाम वालेकुम।
वालेकुम अस्सलाम।
जी सर, क्या हाल है? ठीक है
जी अल्हम्दुलिल्लाह।
सर। आई हैव डन माय बीएस इन सॉफ्टवेयर इंजीनियरिंग फ्रॉम कॉमर्स। तो उसके बाद सर मैं ई कॉमर्स का काम कर रहा हूँ आजकल। होलसेल के अंदर ब्रांड्स वगैरह फाइंड करता हूँ, डाटा एनालिसिस और डेटा रिसर्च करता हूँ उसके अंदर। तो मेरा सवाल सर ये था कि तो एक तो करियर पाथ के हवाले से मुझे सर गाइड करें, क्योंकि मैं डेटा साइंस में कुछ टैबल्यू का और पावर बीआई का मुझे इंट्रोडक्शन है और मैं उस पर काम किया और डेटा वेयरहाउस मैंने पढ़ा हुआ है, बस उसका मेरा कोई प्रैक्टिकल नॉलेज अभी नहीं है। तो सर मुझे बताएं कि एक तो मैं कितने अरसे के अंदर ये टेक्नोलॉजी सीख सकता हूँ। दूसरा सर ये है कि डिग्री करना इसमें ज़रूरी है एमएस की, या फिर प्रैक्टिकल नॉलेज इनफ है? काइंडली ये क्वेश्चन बताइए, आंसर बताइए।
राइट राइट। सो कि बिल्कुल देखें, डिग्री के बगैर डेफिनेटली आप कुछ बेसिक्स मिस कर रहे होते हैं, लेकिन प्रैक्टिकल नॉलेज और ऑनलाइन कोर्सेज की हेल्प से आप बिल्कुल इस फील्ड में आ सकते हैं और एक्सेल भी कर सकते हैं। इफ़ आई गिव यू माय एग्जांपल, मैं बाय एजुकेशन आई एम एन इलेक्ट्रॉनिक्स इंजीनियर। ठीक है, तो मेरा भी यूनिवर्सिटी लेवल पे या एकेडेमिया लेवल पे मेरा कोई ख़ास एक्सपीरियंस या नॉलेज नहीं था अराउंड डेटा एनालिटिक्स। इनफैक्ट मैंने जो सबसे ज़्यादा लैंग्वेज अभी तक यूज़ की है विच इज़ एसक्यूएल, वो मैंने डिग्री में पढ़ी भी नहीं थी। सो देयर इज़ नो लिमिटेशन एट ऑल. You can definitely start off with online courses, and then you can get the foot in the door in this data analytics world.
ओके सर, दूसरा मेरा क्वेश्चन सर ये था कि हम प्रोग्रामिंग लैंग्वेजेस की बात करते हैं, हम बात करते हैं पाइथन का, इसके अंदर बहुत ज़्यादा इंट्रैक्शन है डेटा साइंस के अंदर। तो हम किन टूल्स पे काम कर सकते हैं कि हम प्रोग्रामिंग लैंग्वेजेस को ना यूज़ करें और हमारे पास बिजनेस इंटेलिजेंस टूल्स वगैरह कौन से यूज़ करते हैं? हम डेटा वेयर हाउस है या उसमें काम कर सकते हैं? ये काइंडली
बिल्कुल।
मुझे
सो
थोड़ा सा।
सो आगे हम कुछ टूल्स अभी डिस्कस करेंगे इन दिस सेशन, जिसमें ETL टूल्स भी हैं, जो टूल्स आपको अलाउ करते हैं डेटा ट्रांसफॉर्मेशंस के दौरान डेटा लोड करने के और डेटा एक्सट्रैक्ट करने के लिए। कुछ टूल्स हम डिस्कस करेंगे जो कि बिजनेस इंटेलिजेंस टूल्स हैं, जो डेटा विजुअलाइज करने के या रिपोर्ट करने के लिए अलाउ करते हैं आपको। सो जस्ट होल्ड योर ब्रेथ, वील डेफिनेटली डिस्कस कि आप बगैर कोडिंग स्किल्स के किस तरह से डेटा एनालिसिस में कुछ ना कुछ रोल प्ले कर सकते हैं या डेटा ट्रांसफॉर्मेशंस में।
ओके सर, डन।
थैंक यू।
थैंक यू। थैंक यू सर।
So is there any other participant who would want to say something, because we would want to
Yes,
start
sir.
Yes, sir.
Yeah, I have a little question as well.
इट्स
Sure. Akib, can you mute yourself?
ओके सर, ओके सर, ओके।
Sir, we have a question also.
Yeah, I have just a question. Sir, I just want to find out how long this session is going to be at.
Sorry, Zurez, I couldn't hear you.
I want to find out and how long this session is going to be.
It is scheduled for 2 hours.
Sure, sir.
Yeah.
That would be all.
Numan, you had a question, I guess. Numan Qureshi? Yep.
Yes, sir. Hello, everyone. Myself, Noman. I am currently studying data science from NUST. Sir, actually, my question is, what is the best practice for a student, especially a data science students, to do during his MS period, so he will be ready for job market whenever he finish his masters?
So your question is that what, if I understood it correctly, that what are the things you can do during your degree to be able
Yes,
to,
sir.
gear
Yes, sir.
yourself for the job market? Is it right? Right.
Yes, sir.
Right.
Yes, sir.
Um, so brother, definitely there are, you can participate in different activities within your university. If there are some, assignments related to data analytics, if you are studying specifically data analytics, then there is a lot of room to, gear up yourself for the job market. Just play around with different data sets available on Kaggle, on GitHub, on all the public repositories which you may access over the internet. Go to just subscribe to different business intelligence tools, play around with them. You have lots of public data sets available on Kaggle. You have lots of public data sets available on Azure Data Marketplace, on AWS Data Exchange portal. So you can download those data sets and you can play around those data sets. You can, set up a database on your laptop. You can get a free instance on cloud. It is so easy these days to actually practice all of this stuff and then, gear yourself up for the job market.
Thank you so much, sir.
Perfect. So Mohsen has a question around. So Mohsen says, I have a question. I have done bachelor's in computer engineering. And recently I'm doing ERP related job like process flows, SQL developer. I want to pursue my career in data science. Could you please tell me what sort of courses I have to do before my master's in data science? So Mohsen, there is a long list of courses which Dice Analytics is offering. I would highly encourage you to go to contact Dice Analytics people. And there are other companies in Pakistan as well who are offering different courses around the data analytics. Similarly, you can go to online, training portals like Coursera, Udemy, and whatnot. So you can basically subscribe to or start learning through online courses initially, and then you can, it will help you in your master's in data science in the future. If you have asked another question, if this course is beneficial for pursuing career in data science. So this is basically a 2 hours webinar, right? In which I'll try to give you an overview of databases and data warehouses and the modern world data warehouses and BI tools, right? This will definitely set a baseline, a foundation for you to understand what exactly data analytics is about and data warehouses are about, and then you can subscribe for detailed courses for each kind of subject area within the data analytics ecosystem. So I think we have spent lots of minutes in Q&A and in basic introduction, right? I'll try to answer your questions during the presentation as well, right? And we'll start off with our webinar formally, right? So what exactly is database? People who can speak, who are allowed to speak, can just unmute their mics, and you can tell us about your understanding of databases. Very brief and very crisp in one sentence. If you can define a database, please go ahead. And by the way, we have Adil Iqbal, I think, now with us. Adil bhai, if you can unmute yourself and give us a brief introduction about yourself, I am happy to give you 2 minutes for your introduction and what are your expectations from this section.
Thank you so much. मैंने क्या इंट्रोडक्शन देना है, मैं तो खुद सीखने के लिए आया हूँ। वैसे के साथ बस ये है कि प्रोफेशनली काम किया हुआ है, वेरी गुड गाय। तो मैं तो खुद आपसे सीखने आया हूँ, तो इसलिए nothing more than that. मैं तो खुद एक
right. Chale, I'll take the liberty of introducing you. Thank you very much for joining. Guys, we have Adil Iqbal with us. Adil is currently working in Punjab Information Technology Board. He's I would say he's a top gun there. He's a very senior data analytics professional. He has worked in Teradata in the past. He has worked on numerous projects in Punjab Information Technology Board around data analytics, and he's the guy behind a lot of technology initiatives in Punjab Information Technology Board. And he has done a lot of cool stuff in Punjab Information Technology Board. He has developed a centralized 360-degree profile of citizens of Punjab. He has integrated he and his team has integrated a lot of data sets coming from different departments like like motor vehicle registration authority, like police, like criminal records, like arm registration, like CNIC, data coming from telecom industry. So he has built a 360-degree data warehouse for the Punjab government and for different departments in the Punjab government. So amazing work done by Adil Iqbal in the data analytics industry. So thank you very much, Adil Bhai, for joining the session. So coming back to the other participants. So anyone who want to volunteer and tell us what is the database? What is the database? Maybe you can write in the chat as well. So Zainab, if you are still on the call, I would need your support to read out the questions in the Q&A session and chat. If there is anything important to mention, just let me know, because I find it very difficult to shift between the presentation and the chat section. So Kumar is saying that database is an organized collection of data stored. Perfect depiction of database. I think if you can define a database in one sentence, then this is the perfect sentence for it. A database is an organized collection of data stored and accessed electronically from a computer system. So another participant is saying set of data sources from different sources like database, Excel, web. Yes, this definition is more inclined towards data warehouse. We'll discuss it in detail. So let me give you my perspective or a detailed, introduction of databases. What are the databases? So database is basically a collection of permanently stored data that is used by an application or an enterprise or any other user which may want to access that data, or any application which may want to process some transactions based on that data. So that data can be accessed from the systems which are generally called databases. A database basically contains logically related data, which means that the database was actually created with a specific purpose in mind. मतलब ऐसा नहीं है कि database वैसी बना दी गई. There was a purpose behind it. A database generally supports shared access by many users. So multiple people in the organization, multiple applications in the organization can access the data which is residing in the database. So one characteristic of a database is that many people use it, and often, for many different purposes. It does not have to be developed for a single purpose or a single user. There can be many users, and they can use it for many different purposes as well. So generally, a database, as it is a shared sort of a repository for different people to access that data. So generally, databases are highly secured and protected through control access, and the databases generally maintain the integrity and the value which resides within the data. So one example of the database is a payroll data base, right? Which may include different names of employees, their employee numbers, their salary history, and then the logical relation between different attributes or different data sets within the database. It in this example, you would have, or you may have, a shared access within the organization. For example, if there is a payroll database, then a department, HR department may want to access that payroll database for onboarding of resources and for different purposes, for promotions and stuff like that. So payroll department or the finance department would use this database for generating payrolls and checks for their employees. Similarly, the management can access it for making different decisions. So this is the whole idea about databases. Then there is another term of relational databases. So relational databases are based on relational model. which allows you to actually build the relationships between different types of data. For example, you have a payroll data set, data set, a table which is representing some information around payrolls. Then you have employee profile data set as well. So you might want to, relate these two data sets where you can see that this payroll information is associated with the employees living in Islamabad or in Lahore or in some other city or any other demographic of the employee. So basically, relational databases were founded on mathematical set theory. The relational model uses and extends many principles of set theory to provide a disciplined approach to a data management, right? So that's a brief introduction of databases and relational databases. So these are some of the brand names in the database technologies, which are very common in the market. You would hear about, if you are already working in some organizations, you would definitely have heard about Oracle, MySQL, Postgres, or Microsoft SQL Server. So these are some of the common databases which are being used in the market. So now these databases are basically meant for data processing, right? And for storing the data and for processing the data. Obviously, you would not want to store the data just for a storage purpose. You would want to process it for some particular use case, some particular action, right? So traditionally, data processing has been divided into two different categories, which were OLTP, which is online transaction processing, and DSS, which is known as decision support systems, to basically handle different transactions. And a transaction is basically a logical unit of work, such as updating a record, such as if you are onboarding an employee into your payroll system, then entering the employee detail and storing it in the database, that is one transaction, right? So in online transactional processing systems, these systems were basically developed for managing different business processes. For example, the transaction which takes place when we take out money from ATM. Once your card is validated, a debit transaction takes place against your current against your account, against your balance, to reflect the amount which is withdrawn from the ATM. So there is an update statement being run backend in the database, which actually deducts that amount from from the database, and it actually performs the transaction for you, right? So decision support systems were basically meant for batch reports and for analysis on the data which resides in different systems. So they were designed basically to roll up the different numbers and aggregate different informations to give a bigger picture to the business guys, to be, to allow themselves to perform different, actions related to their business. So these systems were uh, primarily giving the ability of ad hoc analysis as well. So just if you compare it with OLTP systems, it was not only about handling transactions, but it was also giving the flexibility to the users to perform different analysis on it, to perform different ad hoc queries on it, to perform different what if kind of analysis. That what if my customers leave, what if 10% of my customers leave my business, then what would happen? What is going to be my revenue? So Umair Qayyum is raising the hand. Zainab, if you can unmute Umair, I can take a pause here. Yep.
You can unmute him because you have the hosting rights.
It's really tricky to open the participants section while presenting. Anyways, I think I have given him the access. Yes, Umair, please go ahead. Umair, you can unmute yourself and you can speak. I have permitted you to ask questions. Anyways, so moving to Q&A, since we have a pause here. So there is a question where we store the data. So you store the data in databases. Databases are meant for storing the data. You can store the data in file systems. You can store the data in your hard disk. You can store the data in any storage device, which allows you to store any file, right? But you generally store the data in databases because it would serve different purposes, which we were discussing in this slide. You can either store the data in database for processing any transaction. You can either store the data in databases for analysis, for predictions, and for these kind of applications, right?
There's a thing, I want to request all the attendees to note their questions down and ask them in the Q&A session at the end, so that we have a smooth session and cover all the concepts on time.
Yeah. Perfect. So we were mentioning about decision support systems, right? The DSS systems. So those systems were basically allowing you to do different data analysis. So for example, if you want to know that what are your monthly sales of some specific product in your organization, then decision support systems were there to answer these kind of questions for you. So then obviously OLAP systems, which are online analytical processing systems. OLAP basically is a modern form of analytical processing within a DSS environment, right? So there are different OLAP databases in the market, which we'll discuss in the next few slides. Then there are different OLAP tools, which are commonly known as BI tools or business intelligence tools, like some of a participant mentioned PowerBI. That is an OLAP tool, or you can say business intelligence tool. Then there are other tools like like MicroStrategy, Cognos. So these are OLAP tools. Then there are some OLAP databases as well. So these systems basically allow you to analyze your data in different manners and allow you to slice and dice between different data sets and to integrate different data sets into one and present a 360-degree view of your business, right? So, sorry. So if you want to, show a comparison of different segments of your sales, then OLAP systems are there. They can help you. If you want to perform an analysis of, segregating some of the or extracting trends from your data, like what are the top 10 selling items across your business, what are the top 10 performing sales personnel in your company, what are X 10 performing regions in your company. So these kind of questions are generally answered through OLAP systems. And then there is another type of data processing which is very hot these days, that is data mining. So data mining basically involves analyzing more, I would say moderate to large detailed historical data and basically to detect behavioral patterns and basically to detect different patterns which lie within the data to predict future behaviors. So you do data mining on your historical data to get to know what patterns exist, what kind of behaviors which your data can represent, which can be used by different predictive models to predict the future and to predict the likely outcomes which may occur in the future, right? So this is primarily about data mining. An example is that which customers are most likely to respond to one specific promotion, which customers are most likely to leave your business, which are the employees who are going to leave your company. So you basically analyze the historical trend of different customers and different people or different data sets within your organization. And then the models, the predictive models basically try to predict the future based on those historical trends. So this is what is being heavily used in the industry these days. You see the applications of data mining every other day. You have weather apps in your mobile. Those apps basically predicts weather based on historical data and based on current data, based on patterns of movement of the clouds and all that. So similarly, there are a lot of predictive models being developed and being operationalized in your mobile applications. For example, Google Maps that actually gets the information using different readings from your mobile, and then it predicts the traffic patterns, the amount of time which it would take from one place to another place. So there are a lot of predictive algorithms which you are actually consuming every day. So all of those analysis are basically clubbed under data mining kind of stuff. So moving on, this is a basic, there are basically two different types of databases which you will see in the market, OLAP and OLTP specific databases. So OLTP databases are those databases which help you in different business processes and which helps you in, processing different transactions. So the database behind the ATM system, the database behind the CRM system, customer relationship management system, which enters, when you go and open a bank account, there is a CRM system which the guy sitting in the branch is using to enter your basic profile and basic information around you. So that system is an OLTP system, right? The system which is managing your billing in telecom industry. You call one person and there is a balance reduction from your wallet happening right there. So there is an OLTP database in the backend which is performing those transactions for you. Then OLAP systems are basically those systems which are being used as for data analytics, and they help you to do informed decision making within your business. So for data warehouses, we generally use OLAP databases in the market. So this is a basic difference between OLTP and OLAP. So OLTP systems can handle large number of small online transactions. Sorry, Adil Rahman, you have unmuted yourself. Is there any question or it's just a background noise? Can you please mute yourself if you don't have a question? Thank you. So talking about differences of OLTP and OLAP, right? OLTP systems basically handle small online transactions, but a large number of small online transactions, right? OLAP systems are basically developed for handling large volumes of data for analysis purposes. So in terms of querying the data in OLTP systems, you generally do insert, delete, or update. You need to insert one record, you need to update your balance and all that. So these are the basic query trends in the OLTP systems. But in OLAP systems, you perform a lot of complex and technical queries on your systems as well, which requires sometimes aggregations. For example, if you want to see a monthly trend, a monthly report, a weekly report, so you would have to aggregate your data from a transaction level to a month or to a week or to a year to perform analysis on that. So these OLTP systems are generally traditional database management systems, which I showed you in the previous slides, and the OLAP systems are generally used for data warehouses kind of applications. So in terms of data quality in OLTP systems, you have to be very meticulous about the data quality. There is a huge amount of effort which is required to ensure the data quality, because these systems are meant for processing some transactions. So you cannot, you cannot bear with any kind of loopholes from a quality point of view in your data. For example, when you are, performing a transaction, when you are actually, the system actually has to be very careful in terms of data quality, that it deducts the right amount of the money from your bank account, and it deducts from the right account as well. So data quality is very critical in OLTP systems, but in OLAP systems, data quality can be improved with the time, and obviously for right analysis, you will have to have the right quality of data in your OLAP systems as well. But it is not a business critical or a process critical kind of level of quality which you have on OLTP. So in terms of functionality, um, the on OLTP systems are basically processing the data and processing the transactions more of in real time. And in OLAP systems, you generally discover the insights from the historical data, and it has to be in near real time, obviously, to enable you to perform to enable you to smartly make decisions on the base of current trends in your data. But it does not have to be in in real time. So naturally, the speed of transaction in OLTP is going to be very fast because it is meant for handling small transactions but a large volume of transactions. But in OLAP systems, it depends on the amount of data you want to process, and it depends on the volume as well. The more the volume, the more the analysis would be beneficial for you. And the for especially for predictive analytics, obviously you will have to have large volume of data, and you will not be interested in the speed of data coming in, but you will be interested in the larger historical details which exist in your data, right? So this was pretty much about the databases, right? Moving on to the data warehouse, the topic of the day. So we'll try to start off with the traditional data warehouses, and then we'll shift, slowly towards the modern data warehouses which are there in the market. So fundamentals of data warehouse. What exactly is data warehouse, right? So generally, the problem statement when data warehouses came into the picture, the problem statement existed at that time was that there were different systems of OLTP systems, the operational systems in different organizations, which were handling different types of data, right? And different types of operations and different types of business processes. For example, in retail industry, you have point of sales system, you have inventory management system, you have finance and account receivable systems, you have an HR system, you have a customer database or a CRM in your retail business, right? So sorry. So the problem at that time was that all of those databases were in most of the cases, they were in different databases, in different systems, in different computers, I mean, different servers, and in different technologies. So some of the data may reside in MySQL database, some of the data may reside in Oracle or PostgreSQL or some other database, right? So a complexity was there, that the technology was different, the platform itself was different. I mean, you were not actually able to analyze the data in an integrated manner. For example, you have a use case where you would want to correlate your sales with your inventory, so you can replenish the inventory in a timely manner. So in a retail, right? So you cannot perform this analysis, and you cannot predict or you cannot optimize your inventory replenishment unless you integrate point of sale data and the inventory data. Now, how to integrate that data? These two data sets are residing in different types of technologies. One is in Postgres, one is in Oracle. Either you would move all of the POS data into inventory system, or you would have to move all of the inventory system data into a POS system. And you would do the same kind of movement and same kind of lift and shift in every database residing in your company, right? So the problem existed was that the data was residing in different silos, where it was actually being generated by different systems, and where it was actually being used for different transaction processing. But when it comes to analysis, there was a need that these all of the databases or all of the data sets which are residing in different silos, this should come to a centralized location, right? So the basic definition of data warehouse is that a data warehouse is central enterprise-wide database. So your organization-wide database that contains information extracted from different systems. So that's where the term load once, use many comes from, right? So data warehouses are basically load once, use many kind of systems. So you load the data coming from different sources into one repository, and then you use many times for different kind of analysis. So a data warehouse has a centrally located logical architecture which allows you to store the data in a single platform, in single technology, which basically minimizes the data synchronization problems, the data movement problems, and it basically removes the data redundancy as well, because if you have to perform any analysis between inventory and POS, I mentioned that you would have to move all of the POS data into inventory system. Then you have another analysis to perform with the account receivables, because the point of sale system is, for example, it is depicting that Avas has bought 2000 rupee item, right? But he has not paid for it. So account receivable systems can tell you that Avas has not paid for it. So for this kind of analysis, you would have to move all of your data from POS system to account receivable system. So there will be three copies, in fact, of POS data now. One is in an inventory database, one is in POS, its own database, and another copy, the third copy, in the account receivable database. So the better approach is to remove the redundancies and make each copy of each database available in a centralized location, which will allow you to process that data, from a single platform, and which will allow you to integrate that data, to stitch together the data coming from different sources, which definitely would allow you to respond to what if kind of queries, which will provide a single view of business. And then these databases, these data warehouses generally project the data or publish the data using different OLAP tools or business intelligence tools like Cognos, MicroStrategy, and Business Objects to the end users for different analysis. So this was a brief introduction of data warehouses, and this is the data warehouses, the evolution of data warehouses. So coming from top to bottom, the data warehouses actually came into the picture in 1990s, even before that, in 80s. But in 80s, these data warehouses were actually performing basic reporting kind of use cases. So the initial stage typically was focusing on reporting from a single source of data to derive decision making, right? Across different functions, across different business units in the business. And they were typically predefined reports. For example, some of the business users in the organization would request, I need a top 10 performing regions report every morning. I need this report every morning. I need 100 top 100 revenue generating customers report every other morning. I need new sales report every other morning. So these kind of reports, right? But these were predefined reports, and the questions were usually known in advance, and then the reports were being published in daily or weekly or monthly manner, right? So this was basically addressing that what actually is happening in the business. So if I have a retail business, what is happening in the business? What has happened? How much was the sales in last week? How much were the new customers who visited my store? Similarly, in telecom industry, what was the amount of revenue I was getting from my customers in Islamabad? So these kind of reports, right? What is happening? So then the next stage of the evolution of data warehouses was when we started to analyze that. Why is it happening? If there is a specific spike in the sales, why is it happening actually? If there is a spike in the churn rate, if lots of people are leaving your business, if lots of people from, for example, Mobilink are going to Ufone or some other operator, why is it happening? So in this phase, the data warehouses were actually capable enough to answer and drill through the data, the details of the data, that why this specific trend is happening. Maybe the network quality is being dropped. Maybe the price of the the call or any service is not competitive enough, right? Maybe the quality of service the customer is getting, maybe he was not happy with it. Maybe he had some complaints pending in the call center. Maybe the complaints were not being answered by the call center representatives, right? So these kind of problems. So data warehouses were capable enough to give you the detailed information, to enable you to drill through the history of and the details of the data, that if some abnormality is happening, if some thing is happening with your business, then why is it happening? When sorry, when data warehouses were capable enough to tell you that why something is what is happening and why something is happening, then they, the next stage of evolution was that what is going to happen next? What are the hidden patterns? Why, if something is happening, then what is going to happen next? So these predictive analytics were sophisticated, analytics, and being heavily utilized. They were heavily utilizing the system to leverage the information to predict what will happen next in the business proactively, to allow the business users to organize their strategy for their organizations, to manage or to change proactively uh, the outcome which was predicted by these systems, right? So in the next stage of evolutions, when you were analyzing that what is going to happen next, then operationalizing those analytics into your business actually allowed you that what is happening right now, how can we influence those decisions. So it was a predictive kind of stuff happening in the background, but it was more in near real time. So to allow the business users to react actively and to stop something to happen. So in the next phase of evolution, data warehouses were able to activate those kind of analysis and make something happen through automation. For example, the predictive model is predicting that some specific customer is going to leave you because he is having a bad experience in your network. He is having a bad experience with your customer facing employees. So if that is coming from a predictive model, in the activating sort of evolution of data warehouses, the data warehouses were able to perform some actions to stop specific customer to leave your network. For example, if a customer is leaving your telecom network just because he has a calling pattern of calling to UAE or Saudi Arabia very frequently, and some other operator is giving him a special package on international calls to Saudi Arabia or UAE. So your operationalized and automated analytics would automatically develop a product or develop a package for that segment of customers who are leaving your network because of this particular reason, and they will give a campaign or give an offer to the customer that you can subscribe this product or subscribe this offer in this much rupees, and you can solve the problem which you are facing with the current network, with our network, right? Similarly, if another example in the automation is that if in the manufacturing industry, if some predictive model is predicting that a specific machine is going to face a failure because of the readings coming from the sensors, that a specific motor is going, a winding in a specific motor is going to burn out, or it is going to melt, and the motor is going to fail, and it is going to stop its process because of the sensor readings which are coming into the data warehouse, right? So the data warehouse can automatically assign the maintenance team a task that you need to fix this motor because it is going to fail in the next week or maybe in the next month, right? So this is an example of automation, and data warehouses these days are capable enough to, smartly choose what should be happened to avoid some specific event from happening, right? So then another, evolution stage of evolution of the data warehouses are that these days data warehouses are being used for machine learning kind of use cases. So machine learning is basically an approach in which you train your predictive models based on the known data, based on the historical data, and then these models can then be used with the unknown data which is likely to come in the future to predict the future. And these smart machine learning models can actually play not only with the textual data but the audio, video, and geospatial data as well. So these machine learning models can help you again to predict something in the future in a more sophisticated manner. And then the latest or the modern most amount the stage of the data warehouses evolution is that these data warehouses are addressing the needs of the artificial intelligence, the AI sort of problems as well, right? So in AI models, these models are smart enough to predict something from happening and then to perform some action or to assign some action to some resource in the organization and to automate the whole process within a business domain, right? So in today's world, you would be able to analyze what is happening, why is it happening, and then what is going to happen next, and then you would be able to infuse all of these analytics into your business process to make an automation sort of uh, automated sort of process in your business, right? So talking about data warehouses, why do you need data warehouses, right? We have talked about the complexity. We have talked about the different data residing in different silos. We have talked about the need of synchronization or movement between different databases. We have talked about the inconsistencies which may lie if you manage different copies of data in different databases. For example, I mean, one system can show you a picture of 2 hours before. One system can give you a picture of maybe 5 hours before of the same data. So there can be inconsistencies in the data as well. So there are the 5, top reasons, I would say. There are many reasons to adopt data warehouses, but there are the 5 top reasons are you would be able to get a faster access to your data. You would be able to get a consistent and a high quality data. For example, if you have different systems in your organizations and if you don't have the data warehouse, CEO, the chief executive officer, calls a meeting from the and calls finance guys and calls marketing and sales guys in the same room. I can bet because of the inconsistency and because of the synchronization problems between the sales database and the finance database, both of the teams coming to chief executive would give different numbers and would give a different view of their business to the chief executive because of the inconsistencies of the data. When you have an integrated and a 360-degree view of your business, then you resolve the inconsistencies. You have one copy of the data, one true copy for analysis. Obviously, you will have copies in the operational systems which are generating those data, but you will have one single copy for analysis purposes, which will give a single version of truth for all of the data residing in your organization. Another reason why you need data warehouses is that data warehouse allows you to integrate the data in a very easy manner. It is very difficult to integrate all of the source systems if you don't have a single centralized located data management platform, which we call as data warehouse. Then data warehouses keep historical data as well. So this is another reason, because no predictive algorithm can work efficiently or can give you a high accuracy if you don't have the right history of the data, if you don't have the detailed history of the data. And last but not least, the main reason of having data warehouses is to make sense of your data, is to use the data for different purposes, is to use the data for enhancing or improving your revenues, is to use the data for reducing your cost, for reducing your losses, for reducing your outages. It is to make sense of your data, to perform better in your business, to improve the customer experience around your business. In terms of government and public sectors, to improve the citizen satisfaction, to improve the quality of services for citizens, to improve the quality of services in health sector, to improve the quality of services in education sector. So the biggest advantage is that it allows you to make sense of your data and to use the core value of data which resides within your source systems for you. So these are the big names associated with the data warehouse industry. These are the most cool platforms in the data warehouse industries. There is Teradata, which was actually the first data warehouse platform. It was developed in 1970s for OLAP kind of workload for a DSS system. And then in 1990s, it emerged as a data warehouse platform. And in these days, it is a modern data analytics platform, I would say, because it is performing beyond data warehouses. Similarly, Google BigQuery is a new name in the industry, and it is the new shining star in the industry, I would say. Although it is our competitor, but I would definitely have to admit that it is the shining star in the industry. SAP HANA, Oracle, Snowflake, Amazon Redshift, Azure Synapse, and IBM DB2 Warehouse. So these are the data warehouse platforms which are commonly available in the market for data warehouses kind of applications. So we have discussed some basics around data warehouses. Why do you need data warehouses, and what are the brand names associated with it? And let's discuss the common information architecture or information flow within the data warehouses. So on the left-hand side, starting from the left to right, on the left-hand side, you have different data sources which are generating the data. So it can be a CRM system, it can be an ATM database, it can be Facebook, it can be WhatsApp, all of the digital touch points which can generate the data for you. It can be sensors as well. It can be any sort of platform which is generating the data and storing the data. So you generally move all sources, all of the data coming from different sources into one area, which is staging area. And then you move into your the data model which you have developed for integrating different data sources. And then obviously you are not just storing the data into this data warehouse just for the sake of it. You are actually managing the data in a centralized location to address some analytical problems, to address some reporting problems, to address some predictive or data mining problems, right? So, sorry. So you generally develop different data marts, which then answer specific set of analytics or specific set of business users. For example, you integrate all of your data and then you develop different data marts, logical data marts generally, sorry, for marketing, for sales, for a team which is looking after the inventory, right? So this is a common flow, an information architecture flow in the data warehouses these days. Sorry. So how do you populate a data warehouse? I mean, what are the techniques? What are the tools? And what is the basic, flow of information from one point to the target state, right? We have just seen the high-level flow of the data warehouses, and let's just go into the deeper detail on how actually we move the data from OLTP systems to OLAP systems. So there is a process called ETL. You must have heard about it if you are somehow related to data analytics industry. If not, then it's not an issue. We are going to discuss it in deeper detail in this section, that what is ETL and how do you populate your data warehouses, right? So you perform an ETL, extract, transform, and load operation, and you move the data from OLTP systems into OLAP systems, or you can say from the data sources where the data is being generated to the data warehouses where the data is being managed for different analytical use cases. So you extract the data from the data sources. So generally you develop extraction jobs using the native capabilities of the databases. For example, if this database is on Oracle, you will write an extraction script from the Oracle native extraction utility, which will allow you to extract the data from this database into a file. Similarly, you would, if this database is SQL Server, you would use SQL Server native extraction utility, and you will extract the data, bring it into the file. Then you will transform that data and you will load that data into your data warehouse, or you can transform that data after loading into a data warehouse if your data warehouse platform is high performance data warehouse. So generally in Teradata, I have only seen this approach where you load the data into data warehouse and then you transform it for further uses, because the platform is highly performant, and it is able to do that. It is able to do the transformations in itself. Otherwise, you transform the data and then you load into data warehouse, and then you consume that data for your reports, for your analysis, for your data science, predictive models, and all kind of use cases from the data warehouse. So there are different ETL tools. There was a question earlier around the skill set which is required. So if you do not know how to code in the specific language which database allows you, for example, in Python and SQL or in R, or in any other language which the database allows you to extract the data and to transform the data, then there are some GUI-based tools, graphical user interface based tools, which allows you to drag and drop different objects from these tools. Like you can see, this is a database connection connector. Then this is a joiner where you are joining data coming from this source, from 3 and from 5, and then you are loading into this. So you don't have to write the loading script. You just have to drag and drop different objects within the database. So this is these are the ETL tools, commonly known as data processing tools or ETL tools. So the most common ETL tools in the market are Informatica, Talend, and IBM Data Stage. So as I mentioned earlier in the last slide, that there are two ways of doing it, right? There are two ways of populating the data into data warehouse, ETL or ELT. So if you can see in the top section of this slide, this is basically depicting the ETL process, where you extract the data from the different sources, you transform it according to your own requirement. For example, you want to perform filter, you want to mask any information, you want to join information coming from different. So you transform the information. For example, the source system is giving you a full name in one column, and in your data warehouse, because you have some reporting based on last name, and some reporting based on full name, and some reporting based on first name, or maybe you have other requirements of reporting as well, where you need consolidated information. or an integrated information. So you transform the information as per your requirements, and then you load that into a data warehouse, and then you use or consume the data from data warehouse as per your requirements, from the OLAP tools, from the BI tools, from the data science tools, from R and Python for predictive modeling, for different operational systems, from different data sharing systems. And so similarly in ELT approach, you would populate the data warehouse, but in a different approach. You will extract the data from data sources, you will load the data into the data warehouse, and then you will transform it as per your requirement. So remember the information the flow architecture, which we have seen a couple of slides earlier, in which we were populating the data warehouse, and then we were creating different data marts for different users, and then different consumers were accessing it, right? So in that kind of application, you will transform the data within the data warehouse, you will integrate it, and then you will create logical data marts on top of your data warehouse to to publish that data to different consuming applications. So in the next section, we are going to discuss how to design a data warehouse. What are the basic design parameters and how you actually go about it? So one of the things I mentioned is that you need to have a centrally located, integrated, logical data model, right? What is a data model? Data model actually is the organization of the data, like how you organize your data, in which table you are going to organize the information coming from the employee source, or from the payroll source, or from the inventory source, in which table you would organize all of the customer information coming from any source, right? So you'll need to have an integrated data model. So you may have a customer information coming from point of sale system, your CRM system, your call center system, your payroll, not exactly payroll, but your recharging system or whatever, right? So an example which I told you about in the project, which I told you earlier about the public sector example, right? Where Adil Iqbal actually integrated all of the information coming from motor vehicle registration, coming from police sources, coming from criminal records, coming from telecom operators, data coming from driving license system. So you have one citizen, right? You have Awais Ijaz, and you have information coming into your data warehouse about Awais Ijaz from different data sources. So what you need to have is you need to have an integrated data model, which should have one single repository, one single table for all of the information coming from different sources, which is depicting the basic demographics of Muhammad Awais Ijaz, right? So you'll have one citizen table, and you will have one table for example, geographies. You will have one table for provinces, for police stations, for different models of cars and all that, right? So this is the main approach of data modeling, where you have a centralized and an integrated data model, not necessarily integrated, but a data model which should be able to store the information in the right manner, so that it can be used for different analytical purposes, right? So there are different stages of developing a data model. First, you develop a conceptual data model. In conceptual data model, basically it is an organized view of the database concepts and their relationships, that how the sales data will be correlated with product data, or it will be related with stores, and with related with the calendar information and the employee information and all that, right? So in this particular phase, you just organize the data. You just create the building blocks of your data model. And in the next phase, you develop a logical data model. So now we are not talking about moving the data. Actually, we are talking about the design phase. Here, you are not actually moving the data into these tables or these sections, right? You are actually designing the architecture, the blueprint of your data warehouse, that how the data is going to fit in your data warehouse, right? So the logical data model is used to basically define the structure of data elements and to set the relationships between them. The logical data model adds further information to the conceptual data model, and it is one step ahead from the conceptual data model, where you actually define the relationships between different tables. You actually define the names of the tables and the columns which will be in those tables. So you will place the sales data in a manner where store ID will be stored, product ID will be there, date will be there. You define the primary keys, you've defined the foreign keys. These are the basic concepts of relational databases and relational models. And then so basically you define that the information placeholders, the attributes, the columns and the tables. So if you have experience of playing around with the Excel sheets, so you have different columns and different rows, right? So you place the data in different columns and different rows. So that is basically the structure of the information which you are placing. So logical data model allows you to structure that information in a logical manner, and then the physical data model allows you to actually go into a deeper detail, and which allows you to physicalize the information into an actual system, where you define the data types of the columns, where you define the indexes and the primary keys and the triggers and all of the database related, the physical technology related stuff. You develop the physical data model, and the output of physical data models are the definitions of the tables generally, right? So guys, I think we have lots of content to cover, and we have 30 minutes left in this webinar, right? So I'll speed up a little bit, and then I'll try to skim through some of the slides which I have, which may be useful for the people who are related to computer science or data analytics somehow. But for the rest of the audience, this is too much of a technical detail, right? So there are different types of there are different types of data modeling. There is a type which we call star schema, and there is a type which we call snowflake schema. Again, this is too much of a technical detail. I would want to skim it in the interest of time. There is an technique of developing data models, which is called Inmun technique. There was a guy, Bill Inmun, who invented this and developed this technique. Then there is another technique, Kimball technique. There was a guy, Rolf Kimball, who invented this technique. So you can, certainly go to Google and go to online courses to get a deeper information around these techniques. So this is basically the data warehouse in a nutshell. So in a nutshell, you have the data being generated from different sources, be it YouTube, Facebook, any operational system, CRM. Then you have smart connectors, which are allowing you to access that data and allowing you to, extract and load that information into data warehouses. Then you have intelligent data warehouses in between, which are basically managing and consolidating all of the data coming from different sources. And then you have the consumption layer, in which you can see different alerts, you can see different dashboards, different reports. This consumption layer can be anything other than dashboards as well. It can be APIs exposing the data to different applications. It can be data sharing portals. For example, if a call center agent needs to have information around your profile, the customer's profile. So when the customer calls, he actually knows in advance that what type of customer is calling. Is it a high revenue customer? Is it a low revenue customer? Is it an important customer or not? Is it a happy customer or not? Does he have outstanding complaints or not? So these data warehouses can publish the information to different systems as well. These data warehouses can publish information to different BI or OLAP tools as well. So shifting the gears towards the business intelligence and OLAP tools, business intelligence in true essence is a generic term which can be used for different different purposes. It is basically a process or it is basically an ecosystem which helps you improve your decision making. It helps you grow your business. It helps you to identify losses in your business, and it makes the information availability easier for you, and it makes the information sharing easier for you. So this is so business intelligence basically is an umbrella term that combines different tools, different databases, and different methodologies to deliver the right information to the right person at right time in a digestible manner. So by right information to right person, I mean that there would be different stakeholders in the company who would be interested in sales data. There will be different people in the organizations. For example, the top management, they would be interested in the aggregated information. That what is sorry, was there a question? No. So I was mentioning that right person, right data, right person, and right time. So there, for the top management in the company, you would obviously give them the aggregated information, the holistic view of your business. But for the operational teams, you would give them the detailed data, the transaction level data to be able to allow them to perform different actions on the basis of that data. So business intelligence basically encompasses.
I have a question, sir. So should the question be asking at the end of the session, or should I ask in the middle?
In the interest of time, I would say at the end of this session, please.
Sure, sir.
Thank you. Thanks. So as a whole, business intelligence basically covers a wide variety of different terms like data warehousing, data lakes, data governance, data discovery and visualizations, self-service BI, the master data management, and this all is under the umbrella of business intelligence. But commonly in the markets, we use business intelligence terms for OLAP tools or business intelligence tools, or for data visualization tools, right? So the business intelligence tool would look something like this, where you get different reports in front of you. So this is a dashboard from an e-commerce business. So dashboard, just like the dashboard of an airplane or a car, it is aimed towards providing you the necessary information which is required to that specific user to run that business, to run the show, right? In some cases, people would be interested in detailed information. In some cases, like top management, people will be interested in aggregated information and these heat maps and stuff like that. So these BI tools generally allow you to share that data from one department to another department. These BI tools generally allow you to assign someone an action based on these graphs and charts. So for example, if you are analyzing that there is a spike in the data, so you want someone from your team to do a detailed analysis, or to see why is it happening, right? So you can circle it down, you can annotate it, and you can share it with your team member to perform some action or to perform a deeper analysis on it, right? So these are the general principles of BI tools, and generally BI tools help you, or data visualization or business intelligence tools help you to discover key insights of your business, to help you curate the data and visualize the data, to help you in faster decision making, and to help you in improve your business, improve your customer satisfaction, improve your revenues, and to control your losses and control your costs and stuff like that. So these are the common BI tools in the market. PowerBI, MicroStrategy, Tableau, Click, IBM Cognos is there, and so on and so forth. So I would encourage you to have a look at these BI tools, and many of these tools have free desktop versions as well. You can play around with data. You can create these school charts and bar charts and graphical representations of your data without actually knowing any coding techniques. So these are graphical user interface based tools. They allow you to develop different business intelligence reports and different dashboards without knowing too much detail of coding or coding languages, right? So data analytics maturity curves. So data analytics basically, again, your data can be, you can start from raw to cleaned to standard reports, and your analysis could go to ad hoc and OLAP sort of analysis. Then you can do a self-service analysis, self-service BI, which is basically that every other user in the organization have the access to business intelligence tools, and they can slice and dice through different information, and they can drill through and drill down to different aspects of the data, and they can perform their analysis themselves, right? Without any dependency on the IT or without any dependency on the computer programmers or the coders who can actually play with the data and the technical stuff, right? But self-service BI is a technique where data analysts without knowing coding can actually perform these kind of analysis. So this is the maturity stage. We have already discussed the predictive and prescriptive analytics. So prescriptive analytics basically is where the computer or the system advises you the optimized level of actions which should be taken for some specific business outcome. For example, if you need to place cash in the ATM, if the cash is less, then there would be a bad customer experience, or there would be fine from the state bank, right? If your ATM is out of cash. If the cash is not optimal on the higher side, it is more than what is required, then you are essentially paying a lot of more money to basically the movement company, and you are allocating more risk money for the cash which you are maintaining in your ATM. So the prescriptive analytics basically tells you that what is the optimal level of the amount of cash which should be in your ATM on Sunday evening, on Monday evening, on some specific Eid holiday or whatever, right? So this is the maturity curve. Now with this, maturity of analytical techniques, there is, there are a lot of challenges associated with it. Obviously, the amount of analytics are getting complex. The amount of data which is coming into data warehouses is getting, complex, and the variety of data is getting wider and wider. The speed of the data is coming fast and is going faster and faster. So the normal and the traditional data warehouses are basically, not enough for the current needs of the hour, right? Because of the reason that there are a lot of analytical tools coming into the picture. There are a lot of data types coming into the picture. Traditionally, we had structured data only. Now we have unstructured and non-relational data as well. Then the nature of analytics is changing day by day. Initially, we were only reporting the data, and now we have descriptive, predictive, and prescriptive analytics to perform as well. Then automation is there. Artificial intelligence is there. We need to automate the decision making into our business processes. So the data warehouses were initially built, as we discussed, for the integration of data, for bringing that data into one repository, right? But the technology obviously has some limitations, right? So the data warehouses were built for different sort of use cases at that time, and now the expectations from data warehouses or data analytics systems are different. There are different data types coming in. There are lots of new analytical techniques coming in, lots of new formats coming in. Then analytical silos are being developed. So we are back to square one. If I talk about, we were in fact 2 years back, we were back to square one. So initially we resolved a problem of different data silos. We consolidated everything into one platform. We called it data warehouse. Then, with the evolution of different technologies, with the evolution of different data analytic techniques, we resulted into different analytical silos. And I'll just quickly show you how it evolved with the time, and how we now, or at least 2 years back, how we experienced the silos coming into the picture again. So we integrated the customer inventory and all of the data from different sources into data warehouses, and we consolidated everything, right? We resolved the complexity of silos with data warehouses. Then the self-service BI came into the picture, and the data being used with SQL techniques or languages was not enough for all sort of analysis. We had to shift to BI tools, which can talk to data warehouse as well. But there were different teams in the organizations who chose to do custom analytics, and who extract the data from the data warehouses, the integrated data, and started performing the analytics in their own silos, right? Then the cool data scientists came into the picture. They said, oh, come on, we cannot work with this data warehouse technology. We cannot work with Teradata, with Oracle. We want our server. We want our language to develop predictive models, to develop attribution models, right? And some of the data scientists came that we want to work with Python only. So they started extracting the data out of data warehouses and developing the predictive models in Python and R, right? So because at that time, the data warehouses were relational database management systems, and they were usually, addressing the data needs through SQL-like interfaces or through BI tools like Tableau or MicroStrategy. But then the with the increasing complexity in the architecture, it became out of control, and we again reached to the point from where we started the data warehouse discussion, that the silos were again emerged as a problem in the data warehouse industries. So the best that can be said about the previous ecosystem is that users gain access to the tools they need, right? And the analytical solutions in place are often not simple, and they're certainly not integrated. There are different engines for different jobs. There were data movements happening from data warehouses to our server, to some other database for some exploratory stuff, and some Python server. So there were data movements happening. Again, this kind of architecture resulting into silos was not enterprise ready. It was not scalable. So the goal or the objective of modern data warehouses is to bring all of those capabilities into one architecture, to bring, to be able to ingest all kinds of data sources, whether it is in JSON, whether it is image data, whether it is video data, whether it is structured or unstructured data, to perform all of the functions and methods within the platform, within one architecture, do the sentiment analysis, do the custom analysis, and to be able to integrate different engines into one. So for example, R is being executed in a different engine. Spark, which is another data transformation technology, that has a different execution engine. Data warehouses generally have different execution engine. So the sorry, the need of the hour is, or the modern data warehouses are designed in a way that they can have different engines to process the data in single architecture, and they should be able to, process the data in different languages and in different tools, so that the data scientists or the traditional BI users or the self-service BI users would have the flexibility and autonomy to interact with one logical architecture to fulfill all of their analytical needs, right? So modern data warehouses are designed in a way to address all of the needs of the analysis and data sharing and predictive and prescriptive analytics. Modern data warehouses have the capabilities to store the data in structured format and in the lakes as well, in unstructured format, where the people can come in and discover different trends in the data, where they can perform self-service analysis, where they can perform SQL analysis, where they can visualize the data, where they can perform you know predictive models, where they can run predictive models using R Python, where they can develop predictive models, and so on and so forth. So this is primarily about the modern data analytics platforms. There is a brief comparison of these platforms. I will name some. I have already showed you the brand names of these platforms. I would highly encourage you, in the interest of time, obviously I would be skimming those slides, but I will highly encourage you to go and see the details of these platforms, and to see how they enable the capabilities which are essential in the modern data warehousing ecosystem. So this is Amazon Redshift. It allows you to store the data and access the data from S3 kind of object stores. It allows you to process the data using different BI tools like Amazon QuickSight and other third-party BI tools. And it allows you to federate the data from different sources with it. So this is another common or a modern data analytics platform, which is Cloudera Data Warehouse. So you can see the detail in your free time. This has a base layer. This stores the data here. It stores the data here as well. And then it has different engines and different applications which can access the same data in different languages and in different manners. So it has a different application set for data foundation. It has a data flow. It has a different data. It has a different set of applications for data engineering, for data warehouses, for operational data, and for machine learning kind of use cases. So one platform serving all of the requirements for data analytics. Similarly, BigQuery, Google BigQuery is another new shining star in the market, and this is how it gives you all of these capabilities. Microsoft Azure Synapse, this again gives you capability of storing structured data and unstructured data in this layer. It provides you different engines. There is an SQL engine, which is SQL Server, Microsoft SQL Server, and there is an engine for unstructured and structured data both, which is Apache Spark. Then there are different tools available in the consumption layer, and it can publish the data in Microsoft PowerBI, in machine learning, and all other tools in the market, right? And then the Snowflake is again based on the principles of modern data warehouse. It allows you to process different types of data, the sensor data, weblog data. It allows you to develop data warehouses, data lakes, data exchange layers, data applications, and data science related stuff within one platform. And it allows different types of consumer to consume the data. Last but not least, Teradata Vantage. Teradata Vantage is built on an open and flexible architecture, which allows you to store the data in different types. It can be Avro, it can be CSV, it can be JSON, it can be relational. So this data store is internal to the to the platform, and then you can have a native object store where you can have Parquet format data, where you can have unstructured data, where you can have images, videos, and all sorts of data. Then it has an SQL engine, it has a machine learning engine, and it offers in-database analytics. It offers bring your own analytics as well. So you can develop an R Python model, and you can bring that model to be able to execute it within this platform. Then you can use different AI tools, data science workbenches to perform your analytical modeling within the Teradata Vantage platform. Similarly, from a language point of view, you can access the data from SQL, you can access the data from Python or Java or any language of your choice, and you can, serve different types of consumers within your organization or even outside the organization as well. So these modern data warehouses these days are allowing, their users to share that data within the organization and outside the organization as well. With especially after the COVID pandemic, there is a lot more requirement of data sharing across different organizations. The health data has to be shared with different organizations. The mobility data coming from telecom companies has to be shared with government. The banking transactional behaviors, the ATM visits, the branch visits, that has to be shared with the government and health authorities as well. So data sharing is becoming more critical these days, even from a health perspective and from a business perspective as well. Jazz or Mobilink or any other telecom industry, telecom operator would want to get some insights on the financial data, on the business, on the banking data, on the retail data, that how many of our customers are linked with the RAS, how many of our customers want to purchase something on Amazon, so that we can bundle some offer for our customers to improve the stickiness for our customers, right? So data sharing between different businesses is becoming more critical, and these modern data warehouse platforms are now allowing this data sharing across the different organizations as well. So this is for your knowledge and information. This is a brief comparison about these modern data warehouses. It is not coming from myself. It is coming from Gartner, which is a company. They are independent analysts and they rate different technologies, after different benchmarking exercise and all that. So they have a rating for data warehouses. They have a rating for modern logical data warehouses as well. They so you can access this on their website as well, and this is all public information. Whenever you are going into a discussion of choosing the right platform for your requirements, you can access these reports from independent analysts. So coming to the last section of this webinar, the job market and the job roles in the market, right? So job market is crazy these days. I must have to tell you, these days there is a lot of resource crunch we are facing in the data analytics industry. Many companies in Pakistan are still struggling to get the right resources for them. There is a resource crunch in my organization where I am working. There is a resource crunch in IBM. There's a resource crunch in Systems Limited, and all of the organizations who have their feet in the data analytics ecosystem. So there is a lot of requirement of resources, and I would say that in the near future we are not expecting to see any sort of saturation in the market, and that's why this data analytics market is really hot these days. So there are a lot of personas and the job roles in the market. There are business analysts, data analysts. Business analysts are basically the guys who know some business terminologies as well, who know the business of retail, who know the business of telecom or maybe their own industry, right? And who know some sort of basics around data analytics as well. So any of you who is not from a data analytics background can easily be a business analyst with the help of some online courses, right? Similarly, then there are data analysts who actually play with the data, who actually gets information from business analysts, get the requirements from business analysts, and then normalize those information for the architects who design the data warehouses, for the ETL developers who then develops the data warehouses, who code and program the ETL scripts, the transformation scripts, and the physical data model kind of stuff in the data warehouses. Then there are BI analysts who visualize those data, who generates the reports and charts and dashboards for different people in the organization. And then there are consumers in the organization who are consumers and who share the data among their departments and who understands the value which is coming out of these analysis shared by BIs. So these are different roles in the data analytics ecosystem. You can choose one for yourself and you can pick a path and start learning from right now. So these are basically salary statistics from the US market related to data analytics industry. So these job roles and these, roles in this industry are really, really hot in these days. And people are getting real high salaries in this domain. So this is pretty much about it. Thank you very much to everyone for being patient and for listening to me for more than an hour now. I would encourage you guys to ask questions around the webinar or any of the topics we discussed.
We have a question in the comment section from Kashif Nawaz. It's, what are Databricks? And if a person has to create a small data warehouse, which tools you recommend so that it can be hosted on a single machine?
Sorry, what? I missed it.
Databricks.
Databricks is another technology, just like the technologies I mentioned here. So Databricks basically allows you to process structured and unstructured data both. It is primarily focused towards machine learning and deep learning kind of stuff. But it is a very useful technology, which basically allows you to develop a modern data warehouse for your enterprise. Yep. And what was the second part of the question, Zainab? Sorry.
Yes, sir. I have a question.
Sure, please.
So sir, I want to find out so I have 2 or 3 questions. What sort of tools, ETL tools, does the Teradata use as a company? They do have a single tool for their ETL process, or what BI tool they use for their visualizations?
Got it. So as I mentioned, we are a platform company, and we have an open and flexible architecture. So any ETL tool can work. Any ETL tool in the market, you name it, it can work with Teradata.
So it depends upon the employee which tool you want to use.
It depends upon our customers.
Yeah,
it depends upon our customers. Many organizations are using Informatica. Some of the organizations are using IBM data stage. Some of our customers are using Talend as well.
Yes,
some of our customers are using open source ETL tools like Kylo and different ETL tools. Similarly, with the BI tools, there are different options. All of the business intelligence tools you may find in the market are integratable with Teradata. So you can actually access the data residing in Teradata from different BI tools. And same is the case with the data science tools as well. There are different data science like H2O.ai, Data IQ. So we are partners with everyone in the industry, and they can access the data in Teradata. So there's no silver lining about it.
Yes, sir. So one more question is that how in the job market and the people who are using the ETL tools. So I want to find out that how much percent in the job market are using GUI based tools, or how much are using scripting or coding languages for the ETL.
So again, I don't have the statistics of global market right now with me, but in Pakistan, I would say from our customers, from Teradata's customers, I would say from a BI perspective, almost everyone is using GUI-based BI tools. And from an ETL perspective, almost half of our customers are using GUI-based ETL tools, because ETL tools does not only give you GUI, they also give you different capabilities around workflow development, around cataloging, around metadata. There are more than 50% of our customers in Pakistan who are using GUI-based ETL tools.
Sure, sir. And one more question, that if how does your company prefer freshers that they know they have done a little background, or they've done
Yep.
the several projects in data warehousing and business intelligence?
Right. So we have a graduate program. It generally kicks off in May or June timeframe.
Sure.
You should you know connect or you should follow the Teradata LinkedIn page, and they publish these kind of informations there as well. You can connect with me on LinkedIn as well. I generally share these kind of posts. So in May-June timeframe, we usually have fresh graduate program.
Sure. So it's an apprenticeship program, I think so. It's more like an apprenticeship program.
No, it is an employment kind of program.
Yeah, so that would be all. Thank you so much.
It is a 1-year employment program which leads to a permanent employment in the organization.
Sure. Thank you so much, sir.
Yep.
Okay, so the second part was, if a person has to create a small data warehouse, which tools you would recommend so that it can be hosted on a single machine?
Single machine, right? So you can you're going to deploy a data warehouse using Microsoft SQL Server. That is the lightest and the it is not going to be an efficient way of doing it, but still it will allow you to do it. So you can have you can develop it a data warehouse using open source technologies as well. Maybe it's not going to be an efficient way, but still it will serve the purpose. And if you are developing a data warehouse for any organization, then maybe doing everything on a single machine would not serve the purpose. Yep.
Okay.
I hope I answered the question.
Badar Ramzan is asking that I need to know difference between BI analyst and business analyst.
So business analysts are basically those people who know the business terminologies, who basically are the bridge between the technical guys like me in the organization and the business guys who are in sales, who are in marketing, who use their own lingo, who use their own terminologies. So these business analysts basically understands the things of both worlds, and they are bridge between the technical and the non-technical people.
Thank you. We have a similar question, that what is the difference between data warehouse and data lake?
Right. So data lake is basically an area where you land all of your data, where you just push all of your data coming from any source. It may or may not be utilized for data analytics purposes. There may or may not be integration between the data. There may or may not be predictive models running on top of that data, right? So data lake is just an environment where you place all of your data for different kind of use cases. They can be related to data analytics. They can be related to operational data sharing. They can be related to just managing the archival copies, the cold copies of the data. Similarly, there is another question: what is big data for DWS? So big data was a term coined in early 2000 when Hadoop came into the picture, right? So big data is generally high volume, high variety, and high veracity data. Different types of data, different high volumes of data coming in with a very high speed into the architecture, right? So that is the term which is big data, right? So, right, yes. Sorry, there was a question from my daughter in the meantime. Anyways, coming back to you. So big data is generally all of the modern data warehouses, which I showed you in the last few slides. They can handle big data. Big data is just big amount of data and different variety and veracity of the data. So yeah, there was a question in the Q&A session from Bilkis. How can I secure my data warehouse? So there are different user management techniques in the data warehouses, in the databases. You can give access to the people who needs to have access from user management within the database. And then there are different security tools which interact with data warehouses as well. So for example, if you're talking about encryption, there are encryption tools. There are native encryption in databases as well. If you are talking about access of the data, then there are user management techniques. You can connect your database with your LDAP or with your enterprise-wide user management platform, and you can provide access to the people in your organization, right? Then there is another a question in Q&A section. What are the scripting languages that an ETL developer should learn to write scripts? Python is very common these days, but SQL is one which is a mandatory language if you want to do ETL. So SQL is the basic language which you should learn and which you must learn, but Python is the new cool shining star of the scripting languages in terms of data processing.
Yes, sir, I have a question.
Zurez, I'll please allow me. I'll get back to you at the end of the
session.
Sorry,
just a short question. Where will this recording be available?
Yes, that's true. So this recording will be available.
Where it will be available, sir? On Facebook?
You can email us.
Zainab can answer this question. Yeah.
Yes, you can email us for the recording at info@diceanalytics.pk, or you can drop a message at our Facebook page.
Sure, ma'am. That will be all. Thank you so much.
Right. So what is the difference between data warehouse and data lake? SN, I hope I've answered this question. If you still have any further query around it, please feel free to ask. Nasrullah is asking, what is the criteria of tools of which categorized as self-service BI? Is there a tool beside Tableau? Yes, Click, Tableau, PowerBI, MicroStrategy. These are the tools which allows you to give the self-service BI capabilities to your users. Criteria, definitely there are different criteria. Obviously, the cost is one, ease of deployment is one, ease of use is another. So you can pick and choose different between different business intelligence tools based on your requirements. There are multiple criteria around it. So as Rahman has asked how DWH is related to practically big data engineering, specifically in distributed and parallel computing environment. So as in modern data warehouses these days, all of them are parallel computing environment, right? All of them, almost all of them are parallel and distributed based on distributed computing. Big data engineering specifically is basically data engineering, right? Like data transformations, data processing, data wrangling, data quality enhancements, and all that. So that is, big data and data warehouse in these days. It's pretty much the same. It's just a marketing term. But yeah, I mean, practically and technically, it's no different these days. All of the modern data warehouses are big data platforms.
I've got a quick question about what you mentioned earlier during the webinar. It's about ETL versus ELT. So I understand ETL is basically you're extracting data from data sources, you're doing your transformations, and then you're loading them into a data warehouse. But in ELT, you're extracting the data from the data sources, you're loading it directly into the data warehouse. How do you do the transformations when the data is already loaded into a data warehouse?
Yep.
So filters and joins and all that sort of stuff.
No, very good question. So do you remember a slide which I showed you during the presentation, which was depicting the information flow architecture of the data warehouses, right? So there was a staging area. So that staging area is generally, in ELT approach, it is within the platform, within the data warehouse platform. For example, Teradata is your data warehouse platform. You bring all the information in the raw format, in the source format within Teradata, and then in staging area, in a logically partitioned database within the same platform, which is Teradata. And then you transform that data into one integrated model, right? And then you further move that data. So within one database, within one data warehouse platform, you may have different layers of data where you transform the data, then that you keep the detailed information in the data warehouse layer, and then you may have a semantic layer where you keep the aggregated information for your different business segments, right? So there can be different layers in the data platform.
Okay. Definitely makes sense. And one quick question, since we've been discussing about tools quite a bit, PostgreSQL, does that have like a native sort of ETL like tool? It's some work-related stuff that I'm working on. So PostgreSQL is our chosen relational database system. And is there an ETL tool that Postgres comes with?
There's no ETL tool which is bundled with Postgres, but Talend, Informatica, IBM Data Stage, all of these tools can work with PostgreSQL. Talend has an open source version as well, so that is free for you to use. You can explore that.
Yeah, sure thing. Thank you so much.
My pleasure. So Zainab, any other question from the chat? I can see some of the new questions coming in. So just let me answer one more question from a Q&A session. Yaya Bakhtiar is asking how to get started with DWH&BI as a fresh computer engineering graduate. Yaya, companies like Dice Analytics, these guys are doing a good job to enable fresh graduates to be able to get ready for the industry, for the jobs. So reach out to them, reach out to any other company like Dice Analytics, or reach out to or go and subscribe some courses on Coursera, Udemy, or other online platforms. There was a question from anonymous attendee. I import many data sets in Microsoft SQL Server, then cleanse them, then transform this data by applying different business logics, then present this data to end users. Can we say it a data warehouse? Yes, that is a data warehouse. Can we say it ETL with MS SQL Server? Yes, that is ETL with SQL Server. You most probably have used SSIS for ETL. If that is the case, that SSIS is a ETL tool. Zainab, any other question from the chat section?
Let me check.
Guys, you can raise your hand and I can I can let you unmute yourself, or I can allow you to speak if there is a question you would want to ask directly.
SN Rahman is unmuted. SN, please unmute yourself. Basically, he's asking how data warehouse is related to practical big data engineering, specifically in distributed and parallel computing environments.
Yeah, I have answered this question earlier. I hope I have answered you.
Yes, I got this answer. Actually, I want to ask about the certifications to get the entry-level job provided by any famous vendor like IBM, Cloud, Azure. What do you recommend for entry-level jobs?
Yeah. So there are multiple certifications. Certifications are generally technology specific, right? So Teradata has its own certification path. You can see it on Teradata, certifications.teradata.com, or just search on Google certifications, Teradata certifications. So similarly, Microsoft Azure has their own certification path. IBM has their own certification path as well around data analytics. I would highly encourage you to, and in terms of architecture, there are so I would highly encourage you to start from online courses and some courses and certificates of different courses, and then go to technology certifications, because technology certifications are specifically aligned towards the technology itself, not to the industry as a whole, and not to actually developing a data warehouse and all that. So one course for data science which really impressed me a lot was Introduction to data science offered by UCSD on Coursera. That really helped me a lot when I started to learn about data science back in 2015-16. Then there is a course around big data and data lake as well on Coursera. That was really helpful. Then there are a lot of online courses you can subscribe to and learn. And these guys, Dice Analytics, they are doing a wonderful job. Just connect with them and just get an overview of the courses they are offering in Pakistan. So you'll get an opportunity to get the learning face to face. Probably the best way of getting the learning. They have hands-on exercises and workshops as well. So is it, there is another question in the chat. Zainab, where were we in the chat? I can see a lot of questions there. How I can improve our data warehouse inventory? By data warehouse inventory, I'm not sure what exactly you want to ask, but Zainab, if you can unmute, let me just unmute Umair Qayyum so we can get to know what exactly is the question.
Unmuted.
Right. So Umair, please unmute yourself and give us more understanding around your question. In the meanwhile, I would answer another question by Ijaz Ahmed Sumro. Is it necessary to store the data in sequential data storage? No, it is not. Modern data warehouse platforms now can access data from file stores, can access data from their native storages, and can access the data from the cloud object stores as well. So it does not have to be in sequential store. So Yaya Bakhtiar is asking how to get started with DWH and BI as a fresh graduate. I hope I've answered this question live. Bilkis has a question. I prefer Mr. Muhammad that have little demo, for example, of data warehouse and employed to one BI tools. I can certainly request Dice Analytics to arrange it for you, Bilkis. I hope they will probably arrange it. What type of certifications are being offered by Teradata? Okay, I hope I've answered this question. Is it necessary to store data in sequence? No. For entry-level jobs, any recommended certifications? I hope I've answered this. 35 years have background of IT management. Which certification can help further to deep dive into data science? Muhammad Vikas, the first course I would recommend, as I mentioned, is Introduction to Data Science on Coursera, or Introduction to Data Science with Dice Analytics, whichever is feasible for you. Which course by Dice Analytics should I do for entering into data engineering? The course or this course or Elasticsearch? So this is a webinar lesson. Zainab can give you probably more information around the courses which Dice Analytics is offering.
Yes. Basically, Dice Analytics is offering course on data warehouse and BI. It's a 2-month course in which for the first 4 weeks, you will learn SQL from the basics to advanced level. And for the next 4 weeks, business intelligence tools are covered, PowerBI and Tableau.
Yeah. So thank you very much, Bilkis, for your kind comments. Sarah Javed, what would you advise anyone who is starting their career in data engineering in order to excel in the field, right? So my advice would be that you need to, for any kind of field, right? You need to have passion for that field. So if you have a passion for data engineering or data analytics, just live live with it. I mean, I would highly encourage you to subscribe to Kaggle, KAGGLE.com. Go there, download different types of data sets, download Tableau, download Power BI, perform different types of analysis. Go to public.tableau.com. See how people have developed different dashboards. Download those dashboards, play around that data which is in those dashboards and reports. You need to you need to do more sort of hands-on practice on this, and then obviously learn more about learn more and more about this field. So these are my 2 cents on it. I mean, just gear yourself up for the industry, and then you will get the right opportunity, and you will perform well in your career. Nothing can be, there's no substitute of hard work. So spend more time in playing with data and understanding the concepts of logical data modeling, physical data modeling, the data warehouse itself, the architecture of the data warehouses, the information flow architecture, and all that. There is a lot of depth in this field. I am still learning, and there's no point soon I can see that I would have to stop my learning. I'm learning every day. There are lots of new technologies coming in every day. There are lots of new techniques of processing the data coming in every year, every month. There's no substitute of hard work. Just start playing with the data. There are a lot of public data sets available on Kaggle, on GitHub. There are a lot of free ETL tools, lots of free BI tools, which you can install on your laptop, and you can actually play around that. There is a developer edition of Teradata, which can be installed on your laptop. So you can have a Teradata database running on your laptop as well. So get that free version of Teradata database, play around with it, get the free version of Tableau or PowerBI or any other BI tool, play around with it, and focus more on your learnings. That's pretty much about it. Yep. Any other question? Farooq Raza wants to ask a question. He has raised his hand. So Zainab, if you can unmute Farooq. Sarah, thank you very much for your kind words in the chat. I am glad that you guys enjoyed the session. Thank you.
Hello,
G,
can I ask
G,
okay,
sure,
so I
go
just
ahead.
wanted to ask that, like you answered a question, like importing some data sets in SQL Server and then cleansing and then applying business logic. So is this a traditional, is this a recommended way of doing like data warehousing or ETL process, or it is just like someone has this basic set of tools like MS SQL Server and some skills of SQL query writing, so he or she can do this sort of data warehousing or ETL? Is this a recommended way of doing data warehousing or ETL, or this is, or we can say that if someone has this limited set of tools, so that he or she can do the required things this way? This is my question.
So Zainab, can you hear me now?
Yes.
Yeah, so there was a network glitch at my end, I think. Can you please repeat the question for me?
Yeah, sure. I can repeat. I was asking that, to one of the questions in the Q&A, there was a question that if we have a very limited set of tools with us, like MS SQL Server, so if one is importing the CSV or flat files in the MS SQL Server, then cleansing that data using SQL queries, then applying business logics using SQL Server.
Yeah,
so
got it. Yes.
Is this a recommended way of ETL or data warehousing, or?
So Farooq, if the data is coming from different sources and you are essentially putting it into one database, and you have developed a data model for it, which integrates the data coming from different sources, then that is the recommended way, right? There are lots of ways in which you can bring the data into SQL Server and you can cleanse that data, and then you can use it for any other report. It can be through data marts. It can be through proper integrated data layer. It can be through a source-like architecture. If you are moving the data and you're keeping it in the same model which was in the data generating source, then essentially it's not the recommended way, right? And bringing everything into one platform and then using it for the analysis is the recommended way. Now, it depends on the modeling techniques which you are following. It depends on the schema which you have developed. It depends on the requirements you have for your reports. So there are a lot of variations and a lot of variety in the design related stuff. Not single approach can be termed as the best or the recommended approach.
Thank you for your response. Can we expect any other webinar like this on specifically on data modeling, or like the schemas that you just have said? Can we expect any?
I think Zainab can answer this question, but their course outline covers the data modeling techniques in detail. And if you are not, joining their course, then there are a lot of YouTube videos on data modeling techniques, on in-moon approach, on Kimball approach, on Snowflake schema, star schema, and 3NF, which is a normalized third normal form schema. So you can Google it. You can get the basic information from Google. You can watch the YouTube videos, get the basic information from there. Then for a deeper detailed information, contact to Dice Analytics and get their course for that.
Sure, thank you.
So Mansoor has asked a question. Would you please explain some examples on these methods, automated monitoring and alerts? So I believe I've mentioned some of the examples, but I'll give you some more examples around it, right? For example, there is a criminal database in which you have an information of the people who are nominated in active FIRs, right? Then you have a hotel check-in database where you have an information of every person who is checking into a hotel, or you have information coming from Facebook or Google, or location information coming from telecom company. So you get to know that this specific person is in the vicinity of your police station, and this person has an open FIR on his name. Your system, if it is able to give an automated alert to the police station where that person is currently moving. So that is an example of automated alert, right? So the system automatically identifies that the person who is checking into a specific hotel or a person who is moving around Defense Housing Authority is basically a criminal. The system automatically identifies that, and the system automatically generates an alert and sends it to the police station or sends it to some dashboard. Then this is an example of automated alert. Similarly, you get a message of low balance alerts, right? You get a message of 90% usage of your balance. So these are automated alerts as well. When you enter some specific area, or when you move from some specific, when you're moving around some specific area, Google Map gives you an alert to rate that place, right? Or building or park or whatever that place is. So that is an automated alert generated based on your movement and your location. I hope I've answered your question. So would you please send the link of webinar, PPT or recording? Ijaz, I will be happily sharing the PDF version of this presentation with Zainab and the Dice Analytics folks. It's up to them if they can share it with you or not. Zainab can answer this question.
Yes, definitely we'll share it. Please drop a message on Facebook or email us.
Yeah, just send an email to Zainab or anyone at Dice Analytics. You'll get a copy of it. Uzair Malik is saying, what is the difference between agglomerative and divisive hierarchical clustering? So, Uzair, it's a very deep technical question. I would say both techniques are for hierarchical clustering, right? And both techniques used to group objects into clusters based on their similarities. It depends on your model, which if your question is aligned towards which technique you should use. So it depends on the problem statement you have, and it depends on the data you have. So data science is basically an iterative process, right? I would recommend you to apply both clustering techniques to your problem statement and evaluate the results you get out of both techniques, and then pick and choose which should be productionized or which should be operationalized. So both technique will primarily give you the output you want from a clustering model. Ji Mohammad Wakas, please go ahead.
Ji, Assalamu alaikum. Actually, I want to say that I'm ex-student of Dice Analytics. I was on first or second batch, I think so. So I did this BI ecosystem course. Then after, I need a suggestion actually. I'm currently working in some organization in abroad where this type of AFR system, like you can say that ANPR system, automatic number plate recognition system, where alert is generated for specific vehicles. But
right.
What is happening? What is happening that I am working on the operation side. What should I do? Which certification I should go through to deep dive inside the ETL model or something like this? Because we are on the front end application side and we are doing just operations sort of things. That is my question. I need a suggestion that where I should start further that, because I am losing, mean to say, I'm forgetting the things now.
Right. So whatever your organization is, right? First, I think first thing you need to do is you need to change your department, if that is possible. Talk to your manager, talk to the other department's manager, and try to shift from this department to the guys who are managing the database with the vehicle details and with the citizen details and all that, right? You'll get a flavor of ETL in that system, right? The system which is managing the ANPR solution is basically is a real-time analytics system based on computer vision techniques. So if you want to learn more about computer vision on ANPR, I would highly encourage you to learn about different computer vision models like object detection, OCR. You can search about YOLO, YOLO. That is an object detection algorithm. You can search about COCO. This is another library used for object detection. Then there are different libraries like Tesseract for OCR. So I developed an ANPR solution back in 2013-14 for Adil Iqbal, who joined this session earlier. In that particular software or application, my team used YOLO and Tesseract. YOLO for object detection, for detecting the car from a video or a picture, and then reading the number from the number plate with the help of Tesseract library, which is a Google developed open source library which helps you do OCR. So there are different, routes which you can take. I would highly encourage you to talk to someone in the organization who are managing that data. Talk to them and join their team. Yeah.
Actually, I want to add something over here, that we are using the OCR of ARH. Okay, so my organization is basically the government organization, and they are bringing the vendors inside. So still I'm just asking that, is there any Coursera or something like this where we can start like machine learning first or advanced machine learning? So separately beside this, because they are not allowing me to.
Are you in Lahore or Islamabad?
I'm basically in abroad in Qatar.
Oh, right. So whatever that organization is doing, I mean, I can well understand that whatever solution they have brought in is a black box for you, right?
Exactly.
Everything is developed and the logic is basically hidden. So what you can do is you can start, if they offer certifications around their technology, you can start doing that. You can improve their models. There will be an accuracy rate, right? And it won't be 100%.
Definitely, it is 95% or 93% accuracy rate we have.
So 95 is low, right? So when there are false positives coming out of your system, you need to analyze those, and you develop a model for those. You basically, if they allow, talk to them, talk to the database administrators and talk to the system administration guys, tell them that I want to improve your ANPR solution, get the data from them, use any open source technology, develop the ANPR model yourself, and try to improve it using deep learning techniques. I'm sure you will get a better accuracy from their model.
Fine.
So this is the shortcut of moving to that team, right? If you are able to improve the accuracy with 1%, they will definitely welcome you in their team or in their department, and they will give you an opportunity to work with them. This is what I would do if I would be in a same situation.
Okay, I will try my best, and I will contact to DAS Analytics to contact you to you separately if it is possible, so that I will know.
I've just shared my LinkedIn profile in the chat, so you can directly reach out to me via LinkedIn.
Okay. Thank you, sir. Thank you.
If there is any other question, please raise your hand, guys. Otherwise, I will, I will conclude the session. We are already 30 minutes above our schedule. Any other question from any participants who are left? I think it's a no. Silence is always a no. Zainab,
Yes.
So can we conclude the session now?
Yeah, sure. I think that's all about today's webinar. Thank you so much, Mr. Awais, for joining us today and conducting such an amazing and informative session.
You're welcome.
You guys can email us for the recording or any queries regarding our training at info@diceanalytics.pk. Thank you so much.
Thank you very much, everyone, for attending this session, and thank you very much for your patience. I really loved the amount of interaction I had with you guys. I really loved the contribution from your side. It was an interactive session, and it was the way I wanted it to be. I skimmed some of the slides. My apologies. There was a very limited time for that, and I think I spent a lot of time in the earlier introduction session. That was the main cause of it, but I take it on myself. My apologies. You guys can connect directly with me through LinkedIn. I've shared my profile link. Thank you very much for joining in and for listening for more than 2 hours. I really enjoyed the session. Thanks a lot, everyone. Take care. Have a nice evening. Bye-bye.
Bye.
Thank you, Zainab, for moderating it. Bye-bye.
Thank you.